Hey everyone, so this lesson is on the triangle inequality theorem. This chart here is something we usually do in class. It's like somewhat of an investigation. So I'm going to do it, demonstrate it for you. It's not going to have this quite the same effect, but just to show you why this theorem is true. So basically what this section is about is knowing what needs to be true about three potential sides of a triangle in order to make a triangle. So what all these numbers are is I have these straws that are the length of these numbers represent lengths of sides. And basically what we're going to do is figure out, like, can I make a triangle with a side that's 3 centimeters, 4 centimeters, 7 centimeters? Yes or no? I'm not going to necessarily do all of them. Maybe we'll see how long it takes. But then you'll kind of start to see a pattern. And then usually, like in class, we'll talk about why the yeses are yeses and why the noes are noes. And then we'll come up with the theorem together typically. But this is going to be a little bit different. I still wanted to show you what this chart was all about. So the first one is 4 centimeters, 3 centimeters, and I actually lost my straw for 7. So I have this pipe cleaner to represent 7 centimeters. So what I'm going to do is try to make a triangle and see what happens. Before I do it, you might want to think, what do you think? Do you think it'll make one? So I have to put these right on the ends and then try to collapse them in and see if they meet. Oops. To make a triangle. So see how they don't make a triangle? So that means that 3, 4, and 7 is a no. So maybe start thinking about, why is that one a no? Let's see. Now I have 4, 5, and 8. What do we think about this one? Will this one work? Let's see. So here's 8, here's 4 and 5. Move this one over a little bit, this one over. Okay, 4, 5, and 8 is a yes. That made a triangle. So think about, I wonder why that one's a yes, and the first one was a no. 9, 10, and 4. So we have 4, 9, and 10. What do you think about this one? Will this one make a triangle? There's my 4 rolled away easily. So that's a yes. 12, 7, and 6. That one is also a yes. Maybe some of you already have figured out the rule here. 2, 4, and 8. Ooh, I think I don't have my 2 either. I'll do 3. We'll get the same result. So 3, 4, and 8. I don't know why I always have to put the bigger one on the bottom. So here's 3, 4, and 8. Will this make a triangle? No. I may as well just finish them off. 6, 4, and 8. We think 6, 4, and 8 will work. Yes. 6, 4, and 14. Oh, geez, I just dropped one. 6, 4, and 14. What do we think about that? So it's not looking good. Yeah, that's definitely not going to make a triangle. So that's a no. 6, 5, and 13. Also a no. Okay, so what I want you to do is pause it for a second and try to think about why you think the yeses were yeses and why you think the noes were noes. So the reason why the noes were noes and the yeses were yeses is because of this triangle inequality theorem. So let's fill it in. It says the sum of the lengths of any 2 sides of a triangle must be greater than the length of the third side. So the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So if we take a look at the ones that were no's, this one, 3, 4, and 7. So see how 3 plus 4 is equal to 7? It's not bigger than 7. So that's why it was a no. So any two sides that you pick, if you add them together, they have to be bigger than the third side. So like, see how 4 plus 5 is 9, which is bigger than 8. So that's why it made a triangle. 9 plus 4 is 14, which is bigger than 10, also made a triangle. Let's look at another no. 2 plus 4 is 6, which is less than 8, so that did not make a triangle. Same thing with like 4 plus 6, that's 10, which is less than 14. 6 plus 5 is 11, which is less than 13. But all the ones that were yeses, 4 plus 6 is 10, which is bigger than 8, the two smaller sides were bigger than the third side. So that's how you know it makes a triangle. So some of the problems that we do is you're just given three numbers and you're asked to determine if it's possible to make a triangle with those given sides. So technically you're supposed to check all three pairs of sides. Like I'm supposed to check 3 plus 7, is that bigger than 11? 7 plus 11, is that bigger than 3? 3 plus 11, is that bigger than 7? But I don't make you do that. The easiest way to do it is if you just check the two smallest ones, if you add together the two smallest measures and see if it's bigger than the biggest measure. Just doing that will tell you if it's a yes or a no. So I'm going to add that in here. So add the two smallest sides, which aren't necessarily the first two in the order. See over here, it's the last two. So don't go by just the first two in the order. So add the two smallest sides. If the sum is bigger than the third side, it's a yes. If not, it's a no. So that's basically how you would do it. Add the two smallest sides. If the sum is bigger than the third side, then it's a yes. It would make a triangle. If it's not bigger than it, then it's a no. So how you can show work for this, let me zoom in a little bit here, is I like to take the two smallest sides. So 3 plus 7, is it bigger than 11? So I like you to show work that way, like when we have a quiz or something, I know that you actually know the rule. You're not just randomly guessing yes or no. So 3 plus 7 is 10, which is not bigger than 11. So that would not make a triangle. That one's a no. 5, 2, and 3. So these two are the two smaller ones. So 2 plus 3, is that bigger than 5? Well, 2 plus 3 is 5. Is 5 bigger than 5? It's not. So that's also a no. 8, 4, and 6. So 4 and 6 are the two smaller ones. So 4 plus 6, is that bigger than 8? 4 plus 6 is 10, ooh, which is bigger than 8. So there's our first yes. So it's pretty easy. That's the first part, triangle inequality theorem, determining if three side lengths would make a triangle. The last thing that we do in this section is sometimes you are given two values. So if you look at example 2, we're given that 10 centimeters and 4 centimeters are two side lengths. So think about if I had my 10 and my 4. What are some possible values that would make a triangle for the third side? So what are some possible values of a third side that would make a triangle? That's what I'm trying to say here. So usually when I teach this, when we do it in class, I have you guys tell me some possible values that would work. So I just have you like throw out numbers like 5 centimeters. Would 5 centimeters work? Well, let's see. 4 plus 5 is not bigger than 10. So no, 5 wouldn't work. And so we usually we'll throw out some numbers. A lot of times kids will throw out 14. Would 14 work? Well, 10 plus 4 is not bigger than 14. So that's a no. So what about 15? Would 15 work? Not 15, 13 is what I meant. 13 centimeters, would that work? Well, 10 plus 4 is bigger than 13. So that's a yes. So 13 works. Let's see on the low end. So 5 didn't work. But what about 6? Does 6 work? Well, is 4 plus 6 bigger than 10? Oh, no, 6 doesn't work. Okay, so 7 must work then, right? So 4 plus 7 is 11. Whoops, is 11, which is bigger than 10. So 7 works. So a lot of times kids for this will say, oh, well, it's between 7 and 13. But kids forget that there are decimals, like 6.5. Would 6.5 work? Well, 4 plus 6.5 is bigger than 10. So 6.5 would work. What about 6.1? Well, 10 plus 4, I mean, sorry, 6.1 plus 4 is 10.1, and that's bigger than 10. So basically, what I'm trying to get at here is that it's anything bigger than 6 would work. So bigger than 6, but less than 14. So it's like this. This is how we write it. So x is less than 14 and bigger than 6. And so a quick way to get that answer is if you look at 10 and 4, see how 10 plus 4 is 14, 10 minus 4 is 6. Anything in between these would work. 6.1 would work, 13.9 would work, 10 would work, anything in between them. So I'm going to write here just kind of like a general rule. So for the high end of the range, you add the two numbers that you're given. And for the low end of the range, you subtract the two numbers that you're given. So this is like the general rule for figuring that out. So you add and subtract the two numbers. And this notation just means x is less than, or you could say like x is greater than that number and less than this number. So this one you would say x is greater than 6 and less than 14. Or you could say between 6 and 14. That would work too. If you'd rather write it in words, that's fine too. X is greater than 6 and less than 14. However you want to write it. I usually just write it like that. It's a little easier, but whatever works for you. So if you look at these, we have 7 and 18. So our third side is greater than some number and less than some number. Remember, for the low end, you subtract them. So 18 minus 7 is 11. 18 plus 7 is 25. So that means that that third side of a triangle would have to be bigger than 11 and less than 25. For this one, 12 minus 9 is 3. 12 plus 9 is 21. So the two numbers would have to be greater than 3 and less than 21. So that's really it for this section. Those are the only two types of questions that you'll see. It's pretty easy, but if you do have any questions, please don't hesitate to ask. You can come for ACLab or email me. All right, that's it. Have a great day.